Hello everyone. Let's solve the Leetcode question number 872, leaf similar trees. So consider all the leaves of a binary tree from left to right. The values of those leaves form a leaf value sequence. Usually for the people who don't know what is a leaf in a tree, leaf is considered as the last node in that particular branch. Where the leaf is a node which does not have any left or a right values. So for this tree 6, 7, 4 and 9, 8 are the leaves. Now let's see an example. Input will be given in the form of a array. Actually two trees will be given, and we need to just give the sequence of this leaves of this particular tree sequence is equal to the sequence of the leaves of this another tree. So let's see, and we should just give a boolean whether it's a true or a false. If they are equal, that we'll give a true. If not, we'll give a false. Let's see how to solve this problem with an example. If we consider this example, we can understand that there are nearly 6, 7, 4, 9, 8 as our leaves. Let me highlight them with other colors. 6, 7, 4, 9, 8 are our leaves. And if you see, there will be another tree formed if we just convert this into a tree. Let me show you how to convert an array into a tree for visualizing purpose. So the first will be a 3, and the next one will be a 5, and then a 1. So it's completed till here. Now let's go to the next 6 and then 7. Here comes the 4 and 2, and as you see, there are nothing, like the null goes on, and finally we have 9 and 8. So here it comes the 9 and 8. If there is nothing, the next everything goes from left to right. So if you see null, so if we have null, 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 and finally 9 and 8 here. Let me erase this. So let's check what are the leaves in this particular tree. 6, 7, 4, 9, 8, which is exactly the leaves of the other tree. 6, 7, 4, 9, 8. That's the reason the written value is true here. So for me, the intuition, usually I like to solve the tree problems using a recursion. So recursion by default maintains a recursion stack. So the time complexity will be O of n. I mean the length of the nodes. Usually it's in tree terms, it will be termed as height. Height of the tree will be the time complexity, and the space complexity is also the same because we will be getting a recursion stack. It occupies little space. I usually check for traverse. I'll make a DFS call, traverse to each and every root. If we encounter a node which does not have any left or right, I just simply add it into the stack, recursion stack here. In this way, we will be just taking the DFS of one tree and the DFS of other tree, and finally we will just compare these both. If they are equal, we'll just return true. If not, we will just return false. Let's code it up. Initially, I'll just create a function called DFS, which will take root as its parameter. F not root, just return the value, and to check whether if it's a leaf node or not, we will just simply if not root dot left and not root dot right. In that case, we will just simply return the value root dot val, and we need to finally return the DFS of the left tree and the DFS of the right tree. So let's call root dot left, and let's add them. So we get all the left leaf nodes and the right side of the leaf nodes onto into one array. So root dot left plus root dot right. Now we just need to simply call the functions dfs of root dot just root 1. Since we are having two roots here, root 1 will be called once, and finally if let's check if that's equal to the root 2 values. Let's check the values. It's expected true but false. Okay, here the value should be written in the form of an array, because everything needs to be appended at the last. We need to just return everything in the form of an array. As you see, it got accepted now. This is an important point because few test cases are designed in such a way that if they are not appended in an array, we just lose the track of what are the values in that particular list. For checking purpose, you can just see print just dfs of root 1, so that to verify whether the values in them are true, are really getting printed in a correct way. Let's check. I think we need to call this print. As you see, the output of 6798, and here is also 6798. So that's why we got it as that. And let's submit the solution and check. Yeah, it got accepted. So this is the solution. It's a recursive solution to solve this problem. Thank you.